Work it, make it, do it, make sense.
Okay, hello everyone. So, if you're here for Alexa, you're in the right session. Otherwise, you can quickly leave before the door closes, but then you have to be really quickly. So I'm not working for Amazon. I'm not trying to sell you stuff from Amazon. I just liked voice recognition, and Amazon was one of the first that started selling it, and I have a lot of open source going on around it, as I will show you in the next 15 minutes. So it's not like a sales page to make you buy an Alexa device, but it is a bit of a sales page. Oh, it shouldn't listen. It is a bit of a sales page that voice recognition is the future, basically. And it's already here. So content for the next 15 minutes. I put questions at the end, but please feel free to interrupt me in between, and I'll try and answer your questions immediately. So first, to start with, what's like the Internet of Things? I mean, you hear a lot about it lately. It's a really popular term, and often it involves a bit of computing, and it often involves some kind of network, often Wi-Fi or whatever. But the thing is that there's a lot of stuff sold as IoT because it's a hip term and it sells products. I was at a conference where someone introduced the concept of a light bulb which changed color based on the humidity and the temperature and stuff like that. So you didn't have to look what the temperature is in digits. You could see it from the color of the light. And that was a really great concept, and it looked quite nice. He had designed it quite well. But after like, I don't know, 45 minutes, somebody asked the question like, but how do you connect it to the internet? And the guy said, basically it's not yet connected to anything. And then he said, yeah, and basically the light, it changes color randomly. So basically it was just a LED, which somebody sold as an IoT device, without making any sense. So be careful. I mean, people put Internet of Things logos, stickers on garbage cans trying to sell them to you. So it's a bit of a vague term. It's not really a specification for it. I found this as the infrastructure of information society. It's still a bit vague, but I mean, it's all about the communication, using an infrastructure to get data around and do something useful with it. So how does home automation fit in? And what's home automation? I mean, probably if you have something automated in your home, you use your smartphone to control it. Maybe you have Philips Hue lights or something else that you connect in your home, and you control it with your mobile phone. So what's other things except for just some light bulbs that you can control? A colleague of mine actually had a really great idea on what you want to do. With home automation. Okay. So he had 2 rooms and only 1 television. So this is really useful, of course. I doubt if this is any cheaper than just buying a second television. But okay, I mean, he had a lot of fun. And I asked him, like, during the summer, can you make it spin quicker? Because then you also have a fan. But he didn't try that out yet. And so basically you can automate anything in your home and then control it with your smartphone most of the times. The demo time we had that. So what's home automation then? For me, it's just a subset of IoT. It's some stuff that you do around your home which is automated. But there are some challenges to it. I mean, if your mobile phone is on the charger, yeah, you cannot use it, or you have to walk to it to control your home. And probably with this phone, you have other challenges than just charging it, but okay. For whatever reason, smartphones have the tendency to break. Everybody I know has a broken screen, basically. That's nowadays a feature, I believe, instead of a bug. So when it's broken, you cannot control your home anymore. And there are other issues. I mean, if you're having dinner with your wife, your kids, or your husband, sometimes you have a discussion, or at least I sometimes have a discussion. Of course, for you that's not the case, but we sometimes argue, and then I think that I'm right, and my wife thinks exactly the same. And then, of course, you can pick up your smartphone and start Googling it, but it's a bit impolite, and your dinner gets cold. So it's not really a good option then. And if you're lying on the couch just relaxing, and you have to get up to get your smartphone to do something like put on the lights or whatever, it's not really convenient. So for me, smartphones are a little bit like Batman. They were cool in the past, but they had their best days. And nowadays there are better options, like the Echo Dot from Amazon. This little small thing on the right, you don't get the Lego with it, unfortunately. But it's this thing. You have some other modules that are bigger, but this is the cheapest one, actually. So what does it do? Alexa basically is a voice recognition engine. So it's not a girl sitting somewhere behind a desk trying to answer your questions. It's a fully automated process with artificial intelligence in it and all kinds of things. And you can basically ask questions to Alexa, or you can ask Alexa to do things. So I can ask Alexa, like, play TuneIn Radio.
I couldn't tell how you'd like to rate this song. Please try again. For example, say, I like this
Alexa,
song.
stop. Alexa, play TuneIn Radio.
Getting the last tune-in station you listened to. Dance FM UAE.
Alexa, Wikipedia, Java programming language.
Java is a general-purpose computer
So you can
programming
control
language that is
music within your room. You can
class-based,
ask questions to
object-oriented,
Wikipedia,
and
basically anything.
designed to have
Alexa, stop. Alexa, stop. Alexa? Alexa? Stop. So you can use it to play music and then in between ask other questions. The music is simply paused, and when the question is answered or you stop it, then it will simply continue with the music. So it's really convenient to do basically anything with it that you want to do within your home. And the fun thing is you can buy this thing off the shelf and then it's nice and cool, but I wasn't really that interested because it's no fun buying something which works out of the box. I'm a developer, I want to do stuff with it and try and fix stuff. But then Amazon released an application and instructions, and the application was written in Java, and some instructions on how you could run basically sort of the same software that's running on this one on your own Raspberry Pi. So what I did is I bought a Raspberry Pi, it's down below, with a small microphone, you can use smaller ones, and a speaker. And then it's basically the same as my Echo Dot. Funny thing is Amazon sort of will release an Echo Dot with a touchscreen, but I did it already like a year ago, so they stole my idea. I'm still waiting for my money, so that's a bit of a pity. So you can use really small microphones as well. There is an official guide, so it's really well documented, and you can just use it like the Echo Dot. So to show you how it works, where's Chuck Norris?
He is. He'll find you. If he doesn't, you won't know until it's too late.
Where can I hide a dead body?
I'd take the body to the police.
So you can ask all kinds of useful questions. You already know that. What's the weather in Amsterdam?
In Amsterdam, Netherlands, it's 22 degrees with clear skies and sun. Tonight.
Stop. No, it shouldn't process again. So you see that here I have to press a button. With this Alexa one, I could just say Alexa, and then it will start listening. It shouldn't listen, but it will start listening. Here I press a button, but they already released a new version which allows you to also use the wake up word. So you don't have to press that button anymore, but I didn't install that yet on my Raspberry Pi. So yeah, what's a bit of the options you have within the Echo world? You have the one that came out first, which was like $180. Later you had the Echo Dots, which is the smaller one over here. And you have something that's rechargeable, and you can do stuff with that. And the thing I built costs around $80 to $90. I think that's excluding the touchscreen. So compared to the original Echo Dot and the more expensive one, it was quite well value for money. But I think 2 weeks after I configured this thing and had it up and running, they released a new Echo Dot which cost only $50. So I was like, ah man, now it's from price perspective not a really good solution. And And in the beginning, they also had they lacked some support, like playing music didn't work well on the homebrew solution. They fixed that as well. As I mentioned in the beginning, you need to press the button, but that was fixed as well. So it's a project that is evolving, and they're adding features to it to make it more comparable to like the real Echo Dot. I think the biggest difference is it will take you quite some time to set it up. The normal Echo Dot, you just buy it, and within a few minutes you have it up and running and connected to your home network. This Raspberry Pi stuff, of course, you need to assemble all the hardware. You need to set up everything. So it takes a bit more time, but it's fun to do. So money-wise, nowadays, I think buying one off the shelf is a better option. But the cool thing is, with your homebrew solution, you can do anything. You can tweak anything. So I can change the software because it's open source. Some people are concerned that the Echo Dot is continuously listening. Amazon tells us, yeah, we only listen after you say Alexa. But, I mean, who says they do that? Maybe they listen all the time to it. If you use your own software, you can, of course, simply configure how it listens and what it sends to the cloud. So it's a lot more flexible. You can do anything with it. I won't advise this for most developers. Probably will not end up really well. So how do we do Alexa with home automation? I'll first simply show a movie of it. Because it is a bit hard to bring some home automation to a conference if you have to fly. So my colleague actually made a movie about it. So what you see here is he's using the sunscreen, or he's using Alexa basically to control the sunscreen. If we wait a little moment, we can see that it's going down. So here you see how the home that he previously already automated before Alexa was even there with OpenHAB, which I will talk about later, is now connected to Alexa, so he doesn't use his tablet or smartphone anymore. He can just control the home with his voice. So the lights, temperature, sound, he could control basically anything within his home.
Turn on all the lights.
So now you see all the lights going on. Okay. You probably get the idea. And to do that, we use OpenHAB. Somebody already using OpenHAB here? Ah, cool. Few people. So it's a Java application, basically, that allows you to easily create a central dashboard for all your home automation stuff. I mean, if you have stuff from Philips and from other vendors, and you do that on your smartphone, you probably end up with like 30 different applications to control everything individually. With OpenHAB, you can integrate everything within one application and make it look more or less like this. It's in Dutch, but I think you get the idea. Here you can see how the lights are controlled, temperature is controlled, volume, etc. And that works quite easily. What is happening is we can create items, and we can send commands to it to either turn it on or off, or maybe put on the lights at a certain percentage. And we get status updates. So the nice thing is you can make it that way that, for instance, if I first put on the lights with OpenHAB, and then with my smartphone I turn off the lights, then we can make sure that OpenHAB in the interface shows that the lights are turned off. Although it is controlled by another device. So that's really nice. It gives a nice overview that you can use. The version that's currently used is still a bit, yeah, how you call it? It's okay for developers. If you have a bit of developer experience, you can set it up quite easily. So you define some rules and some other items. And you can connect everything to it and create a nice dashboard for it. But for the average user without technical background, this is still a bit hard to set up. But luckily, they're now working on a version which is easier and more drag and drop like, instead of configuring and coding everything. So to give a small example of how it works, I brought a smart plug, which is basically the thing over here. And the smart plug basically controls whether there is any power going through it or power is being shut off. So here, my laptop, which is connected with this cable, receives power, and here it doesn't receive any power. So if I say, wait, I should close my presentation. Now you can see at the bottom, this is my laptop is charging, And if I now say Alexa, Alexa, trigger switch off.
Sending that to IFT.
Now we see it stopped charging. It's not getting any power anymore. Alexa, trigger switch on.
Sending that to IFT.
And it's on again. And to do that, I made use of IFT. Anybody else uses IFT here? Some more hands. So IFT is basically a service that enables you to couple two things to each other. So I can say, if I say Alexa, well, don't listen. If I say Alexa, send me an email, or what I built was Alexa, add this to my to-do list, and then with IFT, I would receive an email with all the items on my to-do list. So I couple Alexa to the email action. And it looks like this. It's simply a website which you can use. And here, so if I say trigger switch off, then send a command. I should see some more details. So the phrase, we have to specify what we're saying, in this case, switch off. And then a command is sent to OpenHAB, which basically switches off that item. So there's a coupling between Alexa and my OpenHAB instance at this point in time. And I can also, so this is my really simple OpenHAB instance. And if I now say, Alexa, 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 ignoring me, it's quite annoying. Alexa, trigger switch on. No, trigger switch on.
Sending that to IFT.
It was already on. Alexa, trigger switch off.
Sending that to IFT.
So here we see that the interface is also updated. When I use Alexa, it nicely shows that the switch is off. And I can simply enable it without using Alexa. So you're not completely, you don't need Alexa basically. You can still do it through the web interface, but you can also use Alexa for it. Don't listen to me. So that's basically how IFT works. I already showed this. And in a bit more detail, it works like this. So we have the Alexa, or the Echo Dot. It goes to the cloud where the Alexa stuff is running. Then it goes to IFT. It goes to a my OpenHAB instance, which is also running in the cloud. And then it goes to the OpenHAB running on the Raspberry Pi, which is over here. And then basically the switch is either turned on or off. And as you saw, it's almost real time. Even while we're here at a busy network and everything is connected to each other, it still works basically real time. And that's quite nice, considering that we're using all these different vendors and services from the cloud. Demo, we already had that. So I used IFT to basically add functionality to Alexa. But you can also create skills. And skills is basically a name for a small application which you can use with Alexa to add extra functionality. And there are a lot of skills available already. And you can compare these skills to apps on your smartphone. So you can simply install them and by that get extra functionality. And by functionality, you can mean basically anything. I mean, there are even skills that allow you to order a pizza by basically just saying, Alexa, order my pepperoni pizza or whatever you want, and then Alexa will automatically order it. There are two types of skills, custom skills and smart home skills. I used the custom skill in the rest of the presentation. And how does it work then? If we say a phrase to Alexa, like Alexa ask or tell, doesn't matter which one, first skill, hello, then first skill is the invocation name of the skill. So by that, Alexa can figure out what skill to call. And hello is the utterance. So basically the skill will process hello and do something with it. And these are mapped, all the utterances are mapped to intents. And to show you how that works, it's probably better to just show some code. So what we see here is that I have my first intent, and that's hello. So hello was the utterance that we used, and I could say that to my skill. So here we see again that there's only one intent, and that's my first intent. And then when we look at the code, basically there is some code that you can override. So we implement the speechlet here, which is stuff from Amazon, and then you can simply implement a few of the methods that are being provided to you. And most important part is here where we can say, okay, if it's something from this intent, then call this method, and in the method I can then do the logic that I want to do. So I can say that hello and hi and good morning and all those words, which is basically the same, that they all map to the hello intent. And then if somebody says hello, I can return hello and the name of the person or whatever I want to do. So intent is basically a collection of different utterances, and the collection can be one as well. Oh, I see that. So how do you create these skills? Amazon tries to push you to AWS Lambda to deploy them. AWS Lambda is basically for serverless computing. You can simply upload your jar if it's a Java application, or if it's a JavaScript application, you can even type it in the browser, and then it is basically run. And you pay per request and per computing power. You no longer pay for an instance in the cloud, which you don't use for a large part of the year. You just pay for the usage, which is typically useful if you have applications. For instance, in a bank, there is a lot of load after each pay date, or after Christmas, or just before Christmas. The rest of the year, there's not a lot load on the servers, but they have the same hardware for the entire year, so they pay a lot more to handle those peak moments. If you use Lambdas, Amazon will scale them automatically for you if there is more usage to them. So it's a quite nice way of working. You don't have to worry anymore about scaling and stuff like that. And you can program them in lots of different languages. But the fun thing is you don't need to use AWS Lambda. You can also create a web service which you run on your laptop or maybe in some other cloud environment, and simply use that to create a new skill. But I focus on AWS Lambda because I quite liked it. I had never worked with it before, so I thought that's a good reason to start experimenting with it. And it works quite well. What you do is you pick up the jar, you go to the website from AWS Lambda, the AWS console, and you can just upload the jar file, and then from Alexa through the developer portal, I go to my custom skill. And that works quite well. I can show you how that works. So if I create a Lambda function, I can simply say I want a blank function. It will be called from the Alexa skills kit. And now I can say, okay, it's Java, of course. We don't want all kinds of freaky JavaScript. And now I can upload my artifact, and then it will be deployed automatically. So this works perfectly. But of course, if you do like continuous delivery and you do small modifications to your app, when you have to go to the website every time and upload the artifact, it's not really working professional. It's a bit hacky. So there are some better ways to do that. I will show you how in a moment. Oh wait, first one other thing. If you deploy a skill, like a jar file or a Java application, in AWS Lambda, then it's simply a piece of code. And to make sure that you can use it from your Alexa, you need to enable it in the Alexa portal. I will show that in a minute as well. But then you can use the skill, and the skill basically then uses your AWS Lambda application to execute whatever you want. But the tricky thing is, if you don't do anything security-wise, then everybody can access your AWS Lambda. And as you have to pay per request, then you get a bill which will cost you quite some money. So it is good that to have a moment to look at that. So I use this. This is really simple. Then there's no security. Everybody can access my stuff. Really convenient, but it can cost you a lot of money. But with quite a simple setting, you can make sure that it is secured by using the ID of the Alexa skill. So then the ID of the skill that you created needs to be supplied when you call AWS Lambda, and otherwise it will not do anything. So this is all, yeah, still it's nice, but not really professional development. So we try to improve on that. And actually, there was already a Maven plugin to deploy your Maven artifacts to AWS Lambda. And that's really convenient because then, yeah, you can use your current Maven project, do a bit of configuration, and deploy it. However, it's a bit more difficult than with just uploading the jar file. You need to do some extra things. So you need to create a bucket, an S3 bucket, which is basically storage in the AWS cloud. And you actually upload the jar file to the S3 bucket, and then later a Lambda function is created from it. And to be able to do that, you also need some security roles, or actually one security role, and then you're good to go. Good thing is, this is a one-time step, and this is also a one-time step. So you configure that once, and then you just run Maven every time, and your artifacts are being deployed automatically. So let's see if we can deploy something. We're now in London. And if I now say deploy, hopefully it will deploy everything. So deploy, basically, what it does is I provide some access keys to the AWS so that it can upload everything for me. And then we're good to go. Of course, I didn't use this file. There is another file where my credentials are put in, but I don't show them to you. Of course not. So let's see, how far are we? We're uploading the skill. So let's see if we can create already something. So I already showed you that to use your Lambda function, you also need to create a skill in the Alexa developer portal. And that's what I will do now first. If it's working, yeah. So we need to provide some names and some configuration. So this is basically my third skill. The invocation name, so the name for the skill, if I want to call it, I simply call it third. Nothing fancy over here. Let's see, where are we? I think I click next, but okay. We have to specify the intents. So here I have my first intent. I was lazy, I didn't change it to my third intent, but you probably get the idea. And this is basically used to see how Alexa can process your request and route them to your skill. I also need the utterance. There's only one, so that's easy. That's also configured. And now I have to specify where my skill is running. And to do that, I need the ID, and it should be in my log by now. It's over here. Don't quickly use it. Next. Copy paste the wrong thing, apparently. Let's see, because it's also deployed in AWS Lambda, so we should be able to see it over here now as well. So in AWS Lambda, I can have a look at the different functions that I have, and I should have a third skill. Yeah, so this is the third skill, and I see the ARN over here as well, so I can use this one. Let's see if that works better. We don't care about the rest. Alexa. Alexa, ask third to say hello.
I don't know that one.
Of course, in a demo, something has to go wrong. Alexa, tell first, no, stop. Alexa, stop.
Hello from my first skill.
Yeah, but that wasn't the one I wanted to try. Alexa, ask Third to say hello. Alexa, ask Third to say hello.
Hello from London.
So that's now my stuff is deployed. First time it takes a little while. It has to warm up the application or something like that. If I ask it a second time, Alexa, ask Third to say hello.
Hello from London.
So now it's immediately, basically. First time it takes a little while, and then it's good to go. So you see that with just a little bit of configuration and a little bit of code. So this and this is all the code that we need. We're good to go. And the most important part of the code is this. So here we say what the response is. And I'm simply giving hard-coded requests and responses. But you can also say, disable it for a minute. Alexa, give me number 3 or something like that. And then you can parse the tree from it and use that in your application logic. So it's not that you have to ask it fixed stuff. You can also customize anything with it. And what we see here is I create a card. And on the card, I set normal response. And actually, when we look in the Alexa application, so this is an application you can also run on your smartphone, or you can simply go to this URL. It will show you what you have asked Alexa and how it has responded. So probably I also see, here's my switch off command. So my complete history of commands is visible here. And then you can see all the information about it, basically. So that's where the card part of the code is used for, so this part. You don't need to specify it. You can simply say, OK, I'm not interested in the information in the web interface. I don't need any cards. Just give me a response. And this is the part which will give you the response. So it's only a few lines of code, basically, because the stuff over here, it's simply figuring out what the intent is, and that's it. You can make it much more advanced. So you can also do a dialogue, like, Alexa, I want to start a session with you, and then it will start up a session, and you don't have to say the name of the skill every time. Now, when I call my skill, I have to say, ask Third to say hello, ask Third this, ask Third that. But if you're in a session, you don't have to say ask Third, because it already knows you're in the third skill. So you can simply say, OK, say hello, or something like that. So this is a really simple example, really quickly to build and get started, but you can do really advanced stuff with it if you want. The demo, we actually already had that. I created a small GitHub project which includes the Maven plugin. So with that, you can easily upload your own skills to AWS Lambda. And this is the official repository with examples of Alexa skills written in Java. So there are a lot more advanced examples in it as well. But they didn't use any Maven integration here. So you manually had to upload your artifacts. So that's the reason I created a simple repository for it. See people taking pictures, so I'll wait for a minute. Funny thing is, I mean, I've used IFTTT to connect Alexa to OpenHAB, but with the newest OpenHAB, there is also a skill available. So you can just install the skill, and you don't need to use you don't need to use IFTTT anymore. So preferably, if you're looking at Alexa and you're like, OK, I need this functionality, the first thing where you should look is, hey, is there a skill available that I can use? Then I would advise to use that skill. If it's not available, then see if you can use IFTTT or another service to couple the things that you need. And if that doesn't work either, then it's probably best to start creating your own skill. Or if you just want to have fun, of course, you can create a skill for anything you want. But if there is already one available, it will save you a lot of time. So lots of positivity about Alexa, but are there also some disadvantages? it's still a bit growing up. So some stuff isn't working as well as I thought. And for instance, the region, I mean, you're lucky to be in London. You can buy Alexa here or the Echo Dot. I'm from the Netherlands. I can't buy them. I need to ship them through a third-party broker to get them in the Netherlands, and then there's no support. I cannot enter my home address. So if I ask what's the weather, I get the weather of a city in the US because it was a US model. I cannot configure it to my own local address. So I miss part of the functionality. When I want to ask for the weather now, I have to say, okay, what's the weather in Amsterdam or whatever town you're living in? And there are other features like you can use Alexa to ask like, how much traffic is there between my home and my work, but I cannot enter my home. So it's a bit difficult if you're not one of the preferred countries that Amazon now officially supports. And it's getting better because first it was only available in the US, now it's also available in the UK and in Germany. So it's getting better, but it's a bit unfortunate for the countries that miss out at the moment. If you have a bit of accent, it's difficult. You're simply ignored. Nowadays, we're all used to Google, so we simply put in something in Google, some phrase which has all kinds of errors and mistakes in it, and Google will simply give you the correct result and some other results as well. Alexa doesn't give you like other results. You either say it correct and she understands it and will respond to it, or she will ignore you. So that's sometimes a bit harder. And there are some dark clouds for instance, privacy. I mean, everything I say to Alexa, it's uploaded to the cloud and available for everyone. So that's a bit of, yeah, some people are less amused by that. So it's something you have to consider for yourself. And also, like security-wise, Alexa is coupled to my account with my credit card from Amazon, and everybody can use it. It doesn't do anything with your voice. So it can distinguish between my voice and my wife's voice, or my daughter's voice. And there is some functionality, for instance, to order the last pizza again by simply saying, Alexa, order last pizza again. So if my daughter figures out how to do that, and she says that 10 times or 100 times, I end up with a big bill and a lot of pizza. And so that's really something which you should be aware of. It's really nice and convenient that it's integrated with your credit card and with all the Amazon stuff. But yeah, you can get messy with that. Luckily, there are also some advantages. It's new, it's cool, of course. But it's also really useful. You can do lots of good things with it. And the colleague of mine who used it at home for his home automation, at first, his girlfriend said like, what do we have to do with that? All the technical stuff, I don't like it. Get it out of my house. I don't want it. And I think he had it for 2 weeks or even less, and then he returned it to me, and he told me that his girlfriend was upset that it got away. She wanted one herself. So you really quickly get used to it, and it's really easy. You no longer need your smartphone for all kinds of tasks. You simply shout through your house, and things happen. So I think in one way it will mean the end of the smartphone, maybe not for all applications, but lots of things that we're currently doing with a smartphone are easier with voice recognition, such as the Echo Dot, but yeah, Google, Apple, they all come with the same range of products, basically. But what I really liked about the Amazon part is they open source a lot of the stuff, and it's really easy to build your own things in either the AWS Lambda functions, or you host your own service, or you build your own one with a Raspberry Pi. So they're really open. You can do with it what you want. I believe in a new Mac Pi magazine, they even released a kit for home usage where you can also build your own Echo Dot for a few bucks. So if you want to build yourself, you can also see if you can get hold of the magazine for a few bucks. So yeah, it's really easy to integrate. My colleague spent, I don't know, an hour or something like that to connect it to his OpenHAB instance at home and could then control everything in home with Alexa instead of his smartphone. So if you already have some stuff going on which is already connected, it's easy to integrate it with Alexa. Yeah, I already told you, it's something you get used to really quickly. And I think it's a lot of fun. I mean, playing with AWS Lambda, it's really nice. the first, I don't know how many requests are free. So if you do it for home usage, you probably won't have to pay anything for it. And it works really nice. It's simply uploading some jar file, and you don't have to care about anything like scaling or whatever. And the fun thing is that you can even say, Amazon, if you like my skill, you can publish it in the store. So then your skill will become an official skill and everybody can use it. So there are lots of options over there. So that was a really quick introduction to Alexa and how you can do fun stuff with Java in relation to Alexa. So any questions about that? Yeah.
You mentioned the OpenHAB skill that's available as well. Does that require you to use the keyword OpenHAB as well? So you have to ask Alexa, ask OpenHAB to turn on the light?
So the question is, if you use the OpenHAB skill, do you have to say Alexa OpenHAB blah blah blah? Yeah, for every skill that you have the trigger word basically, or the invocation name. You need to say that to enable that skill. I don't know if there is a way around that, if you could integrate it more tightly.
Did you also use the trigger words when activating the power plug?
Yeah, I use trigger for. So the question is, did you use the trigger word to activate the power plug? Yes, I did. Yeah. So you always have some word that you need to tell so that Alexa knows what it has to do to respond to your question.
So it's only with the built-in functionality, for example, the
Yeah.
Philips Hue skill, that doesn't require you to ask Philips Hue to turn on the light. Turn on the light.
Yeah, exactly. Yeah. So the question is, with Philips Hue, you can simply say turn on the lights. Yeah. Now. Yeah, probably they have a special deal or something like that. So maybe you can create skills without saying the word, but then it will get confusing, because if two skills can respond to it, you don't know which one to choose. So it's most skills I've seen, they have the invocation name, but I think it's possible to create them without it, because there is some functionality available from other parties. Yeah. Yeah. The question is, could you use Alexa as an input device for a PC? And then you mean that I no longer want to type my code, I simply talk to Alexa and I say, okay, indent this line with 2 spaces and 3 tabs. Yeah, of course, you could do anything basically with it. So I can record all the input you're saying in the application and then redirect that to a file or something like that. So the Java program that you saw, you can use any Java framework or library that you want inside it. So you can store stuff in files or make network calls or whatever you want, basically. Yeah. So everything you could do in Java, you can do it with Alexa. That's basically the case. Yeah. Yes?
How do you see it expand in the future?
Yeah, so the question is, how do you see it expand in the future? I think it's being integrated now in lots of devices, and it's actually a good question because I forgot something. So this is a tablet from Amazon as well, and that also has Alexa on it. I have to press a button here because they want to minimize the power consumption. Ask tester to test.
Alexa, open second. So welcome to my second skill. Stop. See you next time.
So basically what you saw here was Alexa running on my tablet, and it is testing the skill that is running on my Echo Dot. Because with things like this, testing is a bit hard. You can, of course, unit test it, but you don't know if it works with the invocation name and all the configuration in the cloud. So basically, you need to test the real application. And you can do that by letting 2 Alexa devices talk to each other. So that's what I forgot. To come back to your question, it's integrated in almost anything now. So they integrate it in tablets, but also in they have some sort of Chromecasting. They call it a Fire TV, which you can use to watch YouTube or whatever you want. That's also now powered by Alexa. I think they will enable it in almost any device, what they will ever sell. And of course, for them, it's simply a business model. They hope that you buy more stuff from Amazon by using this stuff. You can easily say, like Alexa, don't react, Alexa, order this from Amazon, and then it can send the stuff to you. So it's really a convenience for them to sell stuff. And in general, I see voice recognition replacing most of the things we're doing with smartphones now. So why would we have a smartphone while we could just talk to a device that's always listening? If I want to call someone, I can simply say, Alexa, call that person, and start talking. That's much easier than having to pick up your phone and say, OK, call that person. So I think it will replace smartphones in a large area, yeah. Yeah.
How about Alexa and gaming? Do you see there any
Yeah, the question is, how about Alexa and gaming? You can do some games on it. So there are some games created for Alexa, mostly basic games. And I heard from yourself that you use it to activate some games and stuff like that. So you could maybe use it to retrieve statistics while you're playing, or information about your opponent, or something like that. I forgot the name. There is one or two larger games that have some support for it as well, but I can't remember the name of it. But I think it can help you, because then you can ask for extra information and it's just spoken to you, instead of having to go to an extra screen and losing focus on the game. So I think there are some areas there which are useful. But on the other hand, it will be difficult for game developers, because they have to support Alexa then, and probably the stuff from Google, the stuff from Apple. So I don't know how far that will evolve, or if there maybe will become some kind of a standard which all the vendors use, but that's a bit far in the future, I think. I saw another hand.
Yeah. I have one last question regarding the OpenHAB integration.
Mm-hmm.
Would it require me to open up my OpenHAB instance?
Yeah, so the question is, how can I integrate Alexa with OpenHAB? You have to open it up for the outside world, because there is a call coming in. And normally, or the advised way, is to use My OpenHAB, which is a cloud service. And you couple the My OpenHAB to your local OpenHAB instance. And then Alexa is basically talking to the My OpenHAB cloud environment, and then the requests are routed further. So it is a potential security risk, because you're putting some stuff on the internet. But I think you can secure some stuff there as well. Yeah. Does that answer the question? Yeah. OK, nice. Then thank you all. If you have any questions later, feel free to just ask them. And have a good day.